Welcome to Interpreting BlueSky Fire Weather Forecasts. This tutorial is designed to showcase our fire weather forecast map, found at firesmoke.ca/forecasts/fireweather/current. At the end of this video, you'll be able to recognize map features and understand how to apply our forecast to real fire conditions and behavior in Canada and the United States. Before we can begin, let's talk a bit about BlueSky Canada. BlueSky can be found at firesmoke.ca and has many different tools to aid first responders, governments, and researchers in understanding fire danger, behavior, and smoke emissions in their regions. This includes our smoke forecasts, fire weather forecasts, playground, and downloadable data. This video will focus on the fire weather forecast. As we move through the tutorial, links to reference web pages will be included at the bottom of the screen for your ease of following along. To get started, let's navigate to the forecast. You can find it on our main webpage under the Services tab, or you can use the link at the bottom of the screen. It'll take you to our highly interactive map of North America. The map is defaulted to show the potential fire radiative power, though it has many other layers that we will touch on in this tutorial. Now, there are two main ways to use the map. You can either explore the map spatially, selecting a forecast layer from the drop-down menu and moving through time with the time bar, or you can see the forecast plotted out for a specific location. Let's first explore option 2. To do this, you can use the search bar at the top of the screen to pick a specific location on the map, or simply double-click on the map anywhere within the domain. Selecting the red icon, a pop-up will appear with detailed forecast information for that location. This includes fire weather, fire behavior, weather, and the fuel type for your location. At the bottom of the pop-up, you can change between your local time zone and coordinated universal time. Let's start looking at some features on the Fire Weather tab. The Fine Fuel Moisture Code, Duff Moisture Code, and Drought Code all correspond to different layers of soil, as you can see in this picture. They are all influenced by the weather, but in different ways due to their depths. The top layer, Fine Fuel Moisture Code, often follows a diurnal pattern and is therefore forecasted in hourly intervals, whereas the deeper Duff Moisture Code and Drought Code are less susceptible to the diurnal patterns and are only forecasted daily. For all three, higher values indicate less moisture in the layer and therefore greater fire danger and risk of spreading. Also on the Fire Weather tab are the Built-Up Index, Initial Spread Index, and the Fire Weather Index. The flowchart on the right indicates their dependencies. As you can see, the Built-Up Index is a function of the Duff Moisture Code and the Drought Code. The Initial Spread Index is dependent on the Fine Fuel Moisture Code and wind speed, and the Fire Weather Index is calculated from the Initial Spread Index and the Built-Up Index. The last parameter on the Fire Weather tab is the Daily Severity Rating. This is a numeric rating of the difficulty of controlling fires. It's based on the Fire Weather Index, but it more accurately reflects the expected effort required for fire suppression. Higher values of the Built-Up Index, Initial Spread Index, Fire Weather Index, and Daily Severity Rating indicate more severe fire weather, though they all have different ranges and values. Climatological normals of each of these ratings in the month of July are displayed here, and you can see what areas they commonly affect as well as their ranges of values. These were retrieved from the Canadian Wildland Fire Information System. The next tab in the pop-up is Fire Behavior. Forecasted parameters include the potential fire radiative power, head fire intensity, rate of spread, crown fraction burned, and total fuel consumption. All of these values are dependent on the fire weather forecast values, as well as terrain, elevation, number of daylight hours, and the fuel type. They are all forecasted at an hourly timescale to ensure diurnal patterns are captured. Once again, higher values of all these parameters indicate more severe fire weather. Climatological normals of each of these ratings in the month of July are displayed here, but note that, once again, ranges of values are different for different parameters. Note that the Canadian Wildland Fire and Information System does not have normals calculated for potential fire radiative power, so it is not included here, but it is still an important parameter for first responders, governments, and researchers. More information on most of these values presented for fire weather and fire behavior can be found on the Canadian Wildland Fire Information System webpage, along with methodologies for calculating them. Now we've come to the last tab in the pop-up, which is the Weather tab. This provides the surface level air temperature, relative humidity, wind speed, wind direction, and precipitation for the location of your choice. The meteorology is generated from the Weather Research Forecast Model, developed by the National Centre for Atmospheric Research, and is run by the Weather Forecast Research Team at the University of British Columbia using the North American Mesoscale Forecast System as the initial boundary conditions. A link is provided here for you to navigate to get more information regarding this model if it's of interest to you. Seeing as we've explored the entire pop-up, this concludes this section of the tutorial, but we still have a lot of map features to explore. You can exit the pop-up by clicking elsewhere on the map or by hitting the X in the top right corner. Let's explore the other use of this map, temporal and spatial variability of fire parameters. Clicking on the Layer button in the top right corner, you will find display options that include almost all of the parameters we have previously discussed. Selecting any of these will cause the map to display the forecast, and you can zoom and scroll to see how it varies over the forecast domain. You can also use the time bar in the bottom left corner to move forward and backwards in 3-hour increments. If you click on the time, it will change between Coordinated Universal Time and your local time zone. On the Layers button, you will also now see a new category of options called Observations. Observation layers include point locations of weather stations, satellite detections of fires, Doppler radar, and air quality. Selecting weather stations shows the locations of fire weather stations in North America. Please note that another legend also pops up here to indicate the status of each of these stations. You can click on the individual stations themselves, and a new pop-up will appear with how the fire weather forecast model is performing compared to the observed values at the station over the past 2 weeks, for both the fire weather and weather parameters. This can give you a good indication of the accuracy of our forecast, which will change over time due to the iterative nature of the model. The observed values are the dashed lines, and the forecasted values are the solid lines, and scrolling your mouse over the lines allows for direct numerical comparison. Note that similar to this model, real fire weather observed values are also empirically determined with weather data. Back to the Layers button, if you select Satellite Hotspots, current satellite detections of fires will be displayed across the model domain. You'll notice here that in areas where there are multiple fires, they get conglomerated into a red circle with a number called a fire marker cluster. Zooming in on one of these areas, the location of individual fires is revealed, as well as the estimated fire parameters from the SmartFire 2 algorithm. Note that the locations of these fires are from satellite detections, and therefore may only be accurate up to a few kilometers, so the hotspots should not be taken as exact locations, but rather an approximation for fire activity in a given region. You can also click on the fire icon and see a pop-up for the fire weather, fire behavior, and weather forecast for that area, similar to when we picked our own location to observe the forecast. Back to the Layers button, selecting Doppler radar displays Doppler observations from Environment and Climate Change Canada, and selecting air quality displays North American air quality observations. It's important to know that when an observation feature is displayed on the map, they're denoting real-world phenomena that likely will not exist at the same time as the forecast time. Progressing forward in the forecast maps will change forecasted variables, but observations will stay constant throughout the forecast horizon and only change once new observations are processed through the system. We will now go over some of the last few features of the map. The Home button on the zoom bar will take you back to the original view of the entire domain that you saw when you first entered the site. On the top left-hand side, the 3 bars to the left of the search bar contains the Info menu. This has redirects to the smoke forecast, which will take you back to firesmoke.ca, a link to the Weather Forecast Research Team website, a link for contact information, documentation on how the model was created, user tutorials just like this one, downloadable data, information on the contributors, and our forecast disclaimer. Lastly, the user should be aware that our model is dependent on a numerical weather prediction model that is subject to particular grid spacing, and therefore values are averaged over several kilometers and may vary slightly from exact values at a particular location. This is good to know as weather systems such as storms will be predicted and manifest spots of low fire behavior values. In real life, it's likely, but not a certainty, that there will be an actual storm event causing reduced fire behavior within a few hundred kilometers of the forecasted spot. We have now gone over all the map features that can be used to explore our fire weather forecast. Thank you for your interest in the BlueSky Canada fire weather forecasting system. Should you have any other questions about the fire weather forecast, you can check out the documentation page, which can be navigated to through the link at the bottom right of the screen, or through the info menu as shown previously. This page has a lot of information that could be able to answer your questions. Further questions can be directed to bluesky@eoas.ubc.ca. Check out our other tutorial videos to learn more about BlueSky's services or to take a deeper dive into our forecasts.